In this section, we will discuss solving inequalities. An inequality is a number sentence containing the greater than, less than, greater than or equal to, or less than or equal to symbols. Here's an example. Determine whether the given number is a solution of the inequality x less than 5. Let's start with x equals to negative 4. To determine if the x equals negative 4 is a solution to the inequality, we will replace the x with negative 4 and see if the statement is true or false. So by replacing x with negative 4, we will have the statement negative 4 less than 5. Negative 4 is less than 5. This is a true statement. Therefore, negative 4 is a solution to the inequality. Let's take x equals to 6. If I replace 6 with x, we will get the statement 6 less than 5. 6 is not less than 5. This is a false statement. Therefore, 6 is not a solution to the inequality x less than 5. Now, if you think about this, this is the set of all numbers that are less than 5. 6 is not less than 5, which is why it is not a solution. Because the solutions of an inequality like x less than 4 are too numerous to list, it's helpful to make a drawing that represents all the solutions. So if you think about the set of all numbers that are less than 4, we can have 3, 2, 1, but we can also have 0.99, 0.98. These are all less than 4. We can have 0.001, 0.00001. All these numbers are less than 4, and we have an infinite number of possibilities. It's not practical to list every single value of x that's less than 4. So as a result, we're going to use a graph. The graph of an inequality is such a drawing. Graphs of inequalities in one variable can be drawn on a number line by shading all the points that are solutions. So we would shade every value that is less than 4 in this example. Parentheses are used to indicate endpoints that are not solutions, and brackets are used to indicate endpoints that are solutions. If the inequality is less than or greater than, we will use parentheses. If the inequality has an equal to sign, so less than or equal to or greater than or equal to, we will use brackets. Another example. Graph the inequality and write the solution set in interval notation. Let's take x less than 3. X less than 3, this means we want the set of all numbers that are less than 3. Since we want the set of all numbers that are less than 3, 3 is not included, so we will represent that using a parentheses. The numbers that are less than 3, 2, 1, 0, negative 1, etc., will be shaded in this direction. And since the numbers are getting smaller and smaller, they will get infinitely small and approach negative infinity. In general, when you have a set of values that are less than a particular number, then the values will approach negative infinity since they're getting smaller and smaller. In interval notation, we write the lowest value and the largest value in a solution set. This solution set has no lowest value because the solution set approaches negative infinity. So on the left, we'll have negative infinity. On the right, since all the numbers are less than 3, 3 not including 3 will be the highest value in the solution set. So every number up to 3 but not including 3, we will represent that using 3 and a parentheses. So this is our interval notation. Once you have a graph, interval notation becomes easy. This will be the left value, this will be the right value. Let's graph y is greater than or equal to negative 4. You want the set of all numbers that are greater than or equal to negative 4. Now in this case, we are including negative 4 in our solution because of the equal to sign, the numbers that are greater than or equal to negative 4. So in this case, we will put a bracket on negative 4. And since you want the set of numbers that are greater than or equal to negative 4, we are going to shade this inequality to the right. Since the numbers are getting larger and larger, these are going to approach positive infinity. In interval notation, the lowest value in the solution set is negative 4, which is included. And since the numbers are getting infinitely large, on the right side of the interval notation, we will have the infinity symbol. Since infinity or negative infinity are not numbers, these are concepts that numbers get infinitely small or infinitely big, we will always use a parentheses when using infinity or negative infinity. infinity or negative infinity, always use parentheses. When we solve linear inequalities, we use the steps that we use to solve linear equations with two differences. One, the variable must be on the left side of the inequality. And two, if you multiply or divide both sides by a negative, the inequality reverses. So keep this in mind. If you multiply or divide both sides of an inequality by a negative, the inequality reverses. Here's an example. Solve, graph the solution, and write the solution set in interval notation. Our inequality is 4 times the quantity x minus 5 plus 3x less than 10x plus 1. First, we will distribute the 4. This will give us 4 times x, which is 4x, 4 times negative 5, which is negative 20, plus 3x less than 10x plus 1. After we distribute on each side of the inequality, we'll combine our like terms. 4x plus 3x will be 7x minus 20, and that is less than 10x plus 1. In an equation, we have a choice. If we wanted to, we can move the 7x to the right. But in an inequality, the variables will be always moved to the left side of the inequality. So we will subtract 10x from each side. 7x minus 10x, that's negative 3x, minus 20, less than 1. Now the constants will move to the right side, so we will move the 20 to the right. This will give us negative 3x less than 21. And finally, we will divide both sides by a negative 3. When we divide both sides of an inequality by a negative, the inequality will reverse. So this will become 1. The inequality reverses since we divide it by a negative, and positive divided by negative will give you a negative 7. So in this case, our answer is x greater than negative 7. So let me extend this a little bit. Place negative 7. We want the set of all numbers that are greater than negative 7, but notice it does not include negative 7. So we represent this using a parentheses on negative 7. You want the set of all numbers that are getting larger and larger. So when numbers get larger and larger, they're going to approach infinity. And this will be our solution graphed. In interval notation, we have negative 7, comma, infinity. In the next example, we want to solve the inequality negative 35 less than or equal to negative x. So this time the variable is on the right side, and there's an invisible 1 in the front. So since the x is being multiplied by negative 1, we will divide by both sides by negative 1. When you divide by negative 1, the inequality reverses because we're dividing by a negative. So we have a negative divided by negative, that's a positive 35. The inequality reverses from a less than or equal to a greater than or equal to, and you have the x on the right side. However, in any inequality, the variable cannot be on the right side of the inequality. So we will reverse this and rewrite this as x less than or equal to 35. The inequality will reverse, and we'll write this as x less than or equal to 35. So we want the set of all numbers that are less than or equal to 35. Here's what that would look like. We have a bracket on 35 since we have an equal to sign, so this means 35 is included in our solution set. And we want the set of all numbers that are less than or equal to 35. Less than means we're going to shade to the left, since the numbers are getting smaller and smaller, and they will approach negative infinity. So our interval notation is going to be negative infinity, comma, 35 with a bracket. Next example. Let's solve x plus 5 over 9 less than negative 1 over 6. Since the x is being added by 5 over 9, the inverse of that would be to subtract 5 over 9. So we will subtract 5 over 9 from each side. Now, we need a common denominator when we add or subtract fractions. So between 6 and 9, our common denominator will be 18. This means the 6 will be multiplied by 3, and so the 1 will be multiplied by 3 as well. Negative 1 times 3, this will give us negative 3 over 18. With the 9, to rewrite this using a denominator of 18, we will multiply the 9 by 2. So the 5 gets multiplied by 2, and that will give us negative 10 over 18. Once we have a common denominator, we write the common denominator, and on the numerator, we have negative 3 minus 10. This will give us x less than negative 13 over 18. When we graph this, you want the set of all numbers that are less than negative 13 over 18, not including negative 13 over 18. So on negative 13 over 18, I will put a parentheses. This indicates negative 13 over 18 is not a solution. And since we are looking for the numbers that are less than negative 13 over 18, we will shade left, and these numbers will get smaller and smaller and smaller and approach negative infinity. So again, anytime our inequality is a less than, the numbers are getting smaller and smaller, and therefore they will approach negative infinity. In interval notation, our solution is going to be negative infinity, comma, negative 13 over 18. For our last example, we're going to solve the following inequality, graph the solution set, and write the solution set in interval notation. First, let's distribute the negative 2. A negative times a positive is a negative 4x. Negative times a negative is a positive 2 plus 10, and that is greater than or equal to negative 8x minus 8. Let's combine our like terms on the left side of the inequality. This will give us negative 4x plus 12 greater than or equal to negative 8x minus 8. Now, in an inequality, the variables must always be placed on the left side. So we will add 8x to each side, and this will give us 4x plus 12 greater than or equal to negative 8. Since the 4x is being added by 12, we will subtract 12 to isolate the 4x. This will give us 4x greater than or equal to negative 20. And then finally, we will divide both sides by 4. So we will get x. Now the question is, does the inequality reverse? To determine that, we'll always look at the number that we're dividing by. Since we are dividing by a positive number, the inequality is not going to reverse, even though our answer is going to be a negative 5. Okay, once again, the number we're dividing by is positive, therefore the inequality does not reverse. And our solution will be x greater than or equal to negative 5. So to graph this, we want the set of all numbers that are greater than or equal to, so including negative 5. So we have negative 5, on which I will place a bracket. We want the set of all numbers that are larger than or equal to negative 5, so the numbers are getting larger and larger, which means that ultimately they will approach infinity. Remember that when the set of all numbers are greater than or equal to a number, we're approaching infinity since the numbers are getting larger and larger and larger. So our solution set in interval notation will be negative 5, comma, infinity.